Hi, I'm Dr. Amy Elliott. I'm a manufacturing scientist at Oak Ridge National Lab's Manufacturing Demonstration Facility. Sharing the wonder of science is something I'm passionate about. In fact, I just finished a children's book about this, and I'm so excited to moderate this amazing panel of women for International Day of Women and Girls in Science. We at Oak Ridge National Lab have decided to work with our colleagues at the Department of Energy's Office of Energy Efficiency and Renewable Energy, that's EERE, DOE's best office, if you ask me. I might stop. We're all going to answer questions from students in hopes of inspiring them to pursue careers in science. Let me introduce to you these amazing ladies. First, we have Kelly Speaks Bachman, who is our Principal Deputy Assistant Secretary for EERE. Next, we have Dr. Shin Sun, who is our Associate Laboratory Director in Energy Science and Technology at Oak Ridge National Lab. We have Dr. Merlin Theodore, who leads all of our advanced fiber research at Oak Ridge National Lab. Her carbon fiber recipes are mwah. For Dr. Susan Ham, the Director of Geothermal Technologies in EERE. And last but not least, we have Dr. Cope Corsair, who is our electric grid energy economist. Welcome, ladies. This is going to be a lot of fun. We're going to start with a question from our preschooler group about how we use experimentation in our daily work.
My name is Lagana Experiments.
My work is all on a computer and not in a laboratory, so I don't have test tubes and machines and things like that. But experiments for me is all about being curious. I look at what's the situation that we're in, like what are we looking at, and then how might that be different? And so my experiments are a lot of calculations, but like, okay, here's the things that people are doing right now. If people did things a little bit differently, how would outcomes change for people? So experiments for me are just about asking questions, about being curious. So if you can be curious, you can do experiments on just about anything.
Awesome. Anybody else have any thoughts on experiments?
You can experiment at the very simplest level of like what happens when you put two colors together and you put more of one color than another, and then you see if you can repeat that to get the same color if you really liked it for a different picture or something. I mean, there's so many ways that you can experiment in life with or without the scientific background, but that curiosity really is the key.
Wonderful. Thank you so much. Our next question is about what it takes to become a scientist.
My name is Haley Taylor. I'm in 8th grade. And my question is, how long did it take for you to get to your degrees?
For me, it took 10 years after high school to get a PhD.
That's about what it took me. It took me, 4 years in college and a couple of years for a master's degree, and then some more time to get the PhD, but it was all worth it.
Same for me, Sue and Amy. It took me 5 years to get my undergrad in chemical engineering degree, BS, and then another 2 years to get my master's in mechanical engineering, and then another 3 years to get my PhD in material science and engineering. So about a total of 10 years.
It took me a long time because I didn't go right from high school through my PhD. I finished my first college degree, and then I went out and worked in industry and got to learn what people were actually doing before I went back and did the rest of all of those things up there.
What are the other avenues for getting into science? I mean, there's got to be other things that you don't have to be in school so long for, right? Like baby technician. What are your thoughts on that and workforce development?
That's a great question. Thank you so much. There are so many paths that you can take to get to a scientific, or even just generally ways to change the world, right? So you can do things like the scientific experiments that you ladies all do, and it's so exciting, but there are other ways as well, even insofar as figuring out how like manufacturing facilities can reduce their energy use, how they can, you can take technical school just after high school to figure out like how to help people make sure their businesses and their homes are running as easily as well as possible. There are just a number of paths that you can take and a number of ways that you can get straight into the workforce for helping to clean up our environment and our world in any way that you want.
Awesome. Thank you so much. All right, now we have a run of questions for Kelly. Let's go with the first one.
Hello, my name is Brielle. I am in the 6th grade. My question is our government working on switching all of us with gas-powered cars to electric cars to help stop the pollution the gasoline cars are spreading?
A great question, Brielle. Absolutely, yes. We are doing everything we can. We're doing a lot of research to make sure that we're making electric vehicles that are as powerful and as cost effective as the gas powered cars so that all Americans can have the option to go electric. We help develop technologies that can make the car batteries lighter and last longer. And we're working with state and local governments too to make sure that we can develop the infrastructure that's needed, because nobody wants to be driving their electric car, and not have a charging pump nearby. We are working to put those in all over the country. And luckily, we're not the only ones working on this transition. Almost all the major car manufacturers around the whole country are setting up their own goals to begin making their own new cars electric only in the next decades, like by 2030 and 2040 and 2050. We're all working together to make sure that everyone has a chance to either drive or to ride electric.
Thank you so much. And I'll attest, once you go electric, you'll never want to go back. They are amazing cars.
I just got mine. I want to run errands. It is so awesome. Like, yay, I'm going to the grocery. I have never done that in my life. And now I do that on Saturdays.
Why do the sun get why is the sun so hot and getting away?
I so love that question. The sun is like a huge ball of gases that burn, and they give off a lot of heat. It is so hot that the heat travels millions and millions of miles, and we can still feel it here on Earth. So even though the sun might get in your way sometimes, it get in your eyes, it's actually helping you out. We need it to warm the planet during the day so everything's not so icy all the time. And we can use that heat that comes here to help us in other ways too, like when we take the sun's heat and turn it into energy, and that's called solar power. Solar power can be turned into electricity to power your home, to power your grocery store. I've got groceries on the mind now, to do just about anything that needs electricity.
Awesome. Yes, we do need the sun. All right, the next question is about windmills.
Hi, my name is Christiana Case. I'm in the 6th grade, and my question is, how fast can a windmill go, and how much energy does it produce?
Wind turbines they start to turn when the wind is blowing at about 7 to 11 miles an hour. I think that's like sort of about as fast as you're riding your bike. And most wind turbines turn off when the wind speeds reach around 55 to 65 miles an hour, which is about the speed that your parents drive the car on the highway. And that's to avoid getting damaged. The average wind turbine on land in the United States makes enough energy to power 460 homes. And that means every hour and a half, a wind turbine makes enough energy to power your home for a whole month. But researchers, like the ladies here today, are building bigger and better wind turbines that can capture more energy. So some currently installed around the world create enough energy to power one house for a whole day every time it turns.
That is so fascinating. I had no idea. Shin, one of our students would like to know about the future of fossil energy.
Hi, my name is Julia. I'm in 9th grade, and my question is, how long do you think we have until the fossil fuels run out and we are dependent on clean energy?
Oh, Julia, that's a great question. And thanks for asking that. That meant you have put a lot of thought behind clean energy. Scientists have already shown that if we continue to burn fossil fuels as we have done as human beings in the last, say, 150 years, this Mother Nature, planet Earth, will actually experience irreversible climate change. We've all experienced the wildfires, the floodings, the extreme heat, the last couple of summers, and also the very cold weather last February in Texas, right? These are the outcomes of the climate changes. So it's not about really how long these fossil fuels will last for us. The urgency really comes from, for us to be able to decarbonize our energy sources, to provide decarbonized and clean energy sources so that we can avoid this climate disaster. So the US, our nation, has committed to a set of very, very aggressive clean energy goals. And by 2035, we will have clean electrical grid, decarbonized electrical grid. And then by 2050, we are committed to achieve a net zero carbon economy. So we have really set ourselves some very stretch goals, very aggressive goals to avoid the irreversible climate change.
Thanks, Shen. Do you think you could talk maybe a little bit more about what does the clean energy grid mean?
Clean energy grid means that at some level that the electricity generation and distribution will be net zero carbon. It doesn't mean that it's all renewable sources. It means that, you know, all sources of energy, electricity generation will come into play. Nuclear, renewable, and decarbonized fossil generation in terms of point source capture. So it's going to be all hands on deck for us to achieve that 2035 goal.
Awesome, thank you so much. Our next question is about clean energy and factories.
Hi, my name is Bianca. I'm in the 6th grade. My question is somebody working on a way for factories to make their products using clean energy instead of polluting the air?
That's a great question. Absolutely. You know, we're working with various industries to, first of all, introduce net zero carbon fuel, such as hydrogen and ammonia, for these really hard to electrify industries, right? Such as combustion, aviation industries. Second, we're working on electrifying the process heating using ultrasonic heating, microwave heating, plasma heating, really to electrify the heating industry so that we don't have to use fossil fuel to heat up. Now, the third one is actually, we are, for the really hard ones, like the cement industry, right? We are actually capturing the CO2 from that cement making process to make the process decarbonize. So various ways of electrifying, decarbonizing the processes. We at Oak Ridge National Laboratory were also working on bio-derived feedstocks to decarbonize the chemical industry in terms of feedstocks perspective. So we're really taking a multi-pronged approach to decarbonize industry.
Can you tell us a little bit more about what process heat is?
So process heat is what you take to make things in the process. Let's say, for example, in food drying, right? We all eat potato chips, right? Do we know how potato chips are made, right? These chips are dried, and in the drying process, it's typically using, you know, natural gas heating, right? So what we're trying to do is, can we electrify that process, and can we use even renewable sources to do process heating? And that's only low-grade heat. When you talk about steel making, these blast furnaces, right? Typically, these are run on fossil fuels. Can we use hydrogen for that process? Can we electrify that with the assistance of magnetic field? So all of those are being researched, development, and deployed as we speak at DOE National Labs. So that's why this is a great question. You put a lot of thoughts behind it.
I never thought about that, Shen, but there is a lot of heat used in our manufacturing that is just kind of wasted. So that's a really interesting area to research. Our next set of questions is for Dr. Susan Ham, who is the director of EERE's Geothermal Technologies Office. And she joined our group to answer some questions about geothermal energy. So our first question is about how the school is heated.
Hi, my name is Taylin and I'm in the 10th grade. Our school is heated and cooled by geothermal. Why does each room also need a heat pump?
You asked that question. So every geothermal heat pump system is a little bit different. But what I assume is going on in your school is that there is piping in the yards. There's underground pipes that bring water around, and that pipe brings the underground fluid, whether that's hot or cold fluid, to the geothermal heat pumps in your school. The fluid flows through individual heat pumps, like the ones that you're going to see in this graphic. And these may be on each floor, or they could even be in each room to heat or cool the air that will flow into your classroom and make it the temperature that you and your schoolmates need it to be. The heat transfer from the fluid is controlled by the geothermal heat pump. So that's what regulates the temperature. If you look at this little graphic here, what you're seeing is on the left-hand side, the spring and summer, and on the right-hand side is fall and winter. In the spring and the summer, we want to take the heat from your classroom and dump it back into the backyard, the schoolyard. And in the fall and winter, we want to take the heat and bring it into your room. And so what you're seeing is you're seeing heat dispersion into the ground or heat absorption from the ground into those pipes. And that's what brings the right level temperature water to your room. And then that heat pump will change it and make it whether you want it 68 degrees in your room or 72 degrees in your room. That's why each room or each floor is going to have its own heat pump.
Dr. Ham, why is geothermal so great?
Geothermal is one of the best options out there for renewable energies. First of all, it's carbon free, so it's not putting any carbon emissions into the air, whether you're talking about geothermal heating or cooling or geothermal power production. And what we know about geothermal power production is that if we can harness all of that heat beneath our feet, we could produce upwards of 8 or 10% of the national generation of electricity in a totally carbon-free way within the next few decades. So it's a very flexible type of energy. It can run 24/7. It can heat buildings and communities, and it can power your light bulbs and power your homes. So that's why geothermal is such a great option.
Our next question is about how we use geothermal other than heating and cooling.
Hi, my name's Caitlin. I'm in 11th grade, and my question is, in what other ways besides heating and cooling can we use geothermal technology in our everyday lives?
That is a fabulous question to ask about geothermal energy. Geothermal energy can be used for heating schools and buildings, as you know, is you're living every day in your school, but it can also be used at the utility scale, that is for power production. We can use it to actually power homes and businesses. And because geothermal is a 24/7, what's called a base load energy source, it's available all the time. We don't need to wait for the sun to shine or the wind to blow. It's available all the time. It's also completely carbon-free, which lets us move towards getting towards a carbon-free energy sector by 2050 and really addressing climate change as we go.
You know, I had no idea we could use geothermal for power. That is so awesome. I love it. Okay, thank you so much, Dr. Ham. We're going to move on to questions for Dr. Merlin Theodore, who runs ORNL's Carbon Fiber Technology Facility. And she'll answer some questions about her work at ORNL. The first question is about role models.
Hi, my name is Bellatar, and I'm in the 6th grade. My question is, do you have a female role model? If so, who is it?
Thank you, Bella. That's a great question. I do have several role models. And role models for women in STEM is critical. Our role models are people that I call on every day to give me ideas, to help uplift me, females that I can cry upon, but most importantly, role models that can relate to my challenges and share the same experiences. I have several role models. I will tell you what my top 3 are. I always start with my mother. She's the one that keeps me grounded and shakes me up with me back into shape when things are not going right. My second role model will be Tia Benson Toll. She's Director of Development at Boeing Commercial Airplanes. She's the role model that I use for sharing my day-to-day challenges at my level, how to deal with situations and so forth. And my third role model is Rashana Elamine Foster. She's a peer mentor. She's been my study partner from undergrad all the way through our master's. She's the one that I call upon on a day-to-day basis to help brainstorm ideas, because we always say one day we're going to be rich. So we bounce ideas off of each other and just to say hi sometimes, but she's my peer role model.
Thank you so much. Does anybody else have a role model they want to talk about?
So I would say, Amy, my role model is my mother. She's now 84 years old, and she's a retired professor, chemical engineering, metallurgy, essentially. So she's really taught me how to really just charge through some really difficult times in career life balance. So I would say that she's my biggest force.
Great, thank you so much. Okay, our next question for Dr. Theodore is about projects that you've completed.
Hi, my name's Sarah Richardson. I'm from Copenhagen Central School in New York State, and I'm in 7th grade. What is the most complicated project you've ever completed?
Actually, I have several projects, but I'll talk about one I think we are most proud of at Oak Ridge National Lab and most critical. I wouldn't say so much was complicated. There were complicated aspects of the project, but it was also more so a lot of pressure of completing the project in a short time. When COVID-19 happened, as you all know, we all experienced the COVID pandemic. There was a shortage of a lot of resources. And you guys know there was a rush for toilet paper, right? So in that, there was also a need for, or lack of mask for protection. I think we all experienced that. There were times that you couldn't get any mask anywhere. People were making homemade masks, which was not really giving you the protection that you need. So with that being said, the rise of the COVID numbers was substantial. So the government called upon the national labs in the US to solve a problem across the medical supply chain to help with the lack of resources for the healthcare workers and also for the community. So at Oak Ridge National Lab, we were tasked with several different initiatives. At the carbon fiber technology facility, we were tasked with developing filter media for making N95 masks. So I have two examples of a resultant of that project right here for you to see. So we had to develop the material for making these masks, as well as developing and building some of the equipment required to make the material. It was a lot of pressure because, again, at the time we were during the pandemic and we had the opportunity to work on a real life problem. Although there's a lot of pressure, the beauty of that project is we had a lot of partners that really wanted to help their nation in that situation. So money was not really a concern. It was, let's get this done because we need this now. So I mentioned there was a lack of resources. It was pretty hard for us to get all the raw materials and parts that we needed for the project at the time. Nonetheless, we did find some. It was not the ideal material that we wanted at the time, but we developed a set of experiments to determine which material would work best for making the material that would be NIOSH certified. So once we did that, we then transfer all of the technology with an industry partner here in Tennessee, who are now making enough material for 1 million masks a day. We also partner with another medical company in the state of Florida, and they're the ones that are producing the mask from that material. And they're making 500,000 N95 masks a day and 3 million surgical masks per day. They also hired 1,500 people, and that was done in a period of 6 months. This is from experimentation to actual commercialization. These masks are now NIOSH certified as well as FDA approved and is a US supply chain. So it was complicated because we couldn't find the resources at the time, but even more so, it was a lot of pressure because we had to get this project done immediately to help our nation. Thank you.
Awesome. Great job, Merlin. I think a lot of us know about that story and are just so proud of you and so grateful that you're here at Oak Ridge with us. Just couldn't be prouder of your accomplishments, not just this project, but others as well.
Well, it took the entire team, Amy.
Awesome. Yeah, of course. Yes. And that's a good point about a science career is, you work on teams. It's so great that you can have colleagues and all of these people that help on projects like that. And you really form a great bond with the people that you work with. So,
Amy, I do want to mention that we also had the opportunity to work alongside the renowned Dr. Peter Tsai, the original inventor of N95 technology. So the opportunity to work side by side with individuals or experts in these technology area is definitely a possibility.
That's right. He's right here in Knoxville. Who would have thought, right?
And this really is a great example where, in a STEM career, you could rise up in the case, in this case, it's COVID, right? Really to have national level impact, right?
I think that's something that we all cherish, is the opportunity to make an impact on the lives of the people around us and our nation. Our next set of questions is for Dr. Hope Corsair, and she's an energy economist working to make sure our scientific discoveries have the widest possible impact, which is so important. And her first question is from a 7th grader who would like to hear about climate change.
Hi, my name is Ariana Doyle. I'm in 7th grade at Copenhagen Central School in New York State. My question is, what advice would you give a 7th grader to help fight climate change?
The big impacts, the ways that you can really make a difference in the long term, have to do with really what you decide to do for your career. What can you do in terms of science, and what can you do in terms of communication, and what can you do in terms of all the things that we need to be able to not just come up with the discoveries, with the inventions and the ideas that are going to reduce climate change, but also how do we get those communicated to people? How do we get people to come along and go along with these things? And really important, how do we make sure that it's affordable for people? So for you right now, one of the most important things you can do, and you may not want to hear this, is study your math. but studying math and science and writing and all of the things that are most interesting to you, and try to keep them in context, right? Well, why are you doing algebra today? Well, this is actually what you're going to need in order to be able to do, whether it's physics or economics or any of those things. That's you're going to need that eventually. But in terms of what you can do right now, and what everybody can do every day, it's the small things that make a really big difference. It's not try to change everything all at once. Try to change little things just a little bit at a time. Like, you think about all the things that you do that actually make a difference, and you might think just this little difference isn't really going to change anything, but a little difference that you do and all your friends do and all your family do and everybody does over a long period of time starts to make a really big difference. So, energy, using energy creates climate change. So what happens if you just take a shower that's a little bit shorter, right? You know that eating a lot of meat can have a climate impact. What happens, don't try to, throw it all away and go vegan right now. What happens if you just get your pizza without pepperoni? What are the little things? Think about the things that you do every day and the way that they have an impact, and think about how you can make just little changes today and stick with them. And then a few more little changes tomorrow and stick with those, and a few more little changes. And that'll make the biggest impact overall, much more than trying to do something grand that you're not going to be able to stick with.
I love that answer, Hope. I would like to add that, we tend to worry about how, math is, can be hard. But I like to think of math as, it's like a sport, right? Were you good at a sport or, a hobby the first time you tried it? No, you had to practice. There are drills. You have to, it's like a sport for your brain. And so if you just kind of think of it that way and let yourself, make a few mistakes, it's okay. But math is so important. And once you get to kind of understand math, and this light bulb, this click will happen in your brain, and you'll start to love math. I promise, if you just work at it. And it's so worth it. There's things you can do with math that you really can't do without it. So we're solving all these problems using math, and it's actually pretty fun.
I have a confession to make that I can't believe I'm going to make in this company and in public like this. I actually never found math all that easy, right? Math was always a little bit hard for me, but math is it's a tool and a language. It's a hammer or a saw in my toolbox, and I'm building. I'm not building tables that I need my hammer and my saw for, right? I'm building science, and math is my tool for that. So even if it's not the easiest thing in the world for you to do, that's okay. It's a good thing to have. It's a good thing to do, and like Amy said, it's going to take some practice and it's going to take some mistakes, and that's okay. You don't have to get 100% on every math test to want to go into science or engineering or economics or any of these things.
I hope I want to add to that. I have to admit as well myself, I hated math with a passion. And because I had that in my mind that I hated it, I just didn't want to do it.
Mm-hmm.
But then I realized to be an engineer, I had to do math. I had to take all of the math. So once I changed my mindset and I started doing math, I made it a goal to do math every single day. it became so easy that when I got to the higher levels of math, I was like, even though it took about 10 pages for one answer, it was so easy to me is because I put the time in and I got that out of my head that math is hard. It was so easy. I actually was embarrassed by it. I was like, I should have just felt like this from the beginning.
Great answers, ladies. I love that so much. All right. Our last question is for Hope again, and it's about her projects.
Hi, my name is Ava Nunes and I am in 6th grade. My question is, what is your most challenging project and is it your best work?
Great question. Thinking about whether your hardest projects are your greatest projects or your best work, that's a hard thing to answer, because to say what my best work is always an interesting challenge, because I want to know, well, best in what way? I can tell you some of the most challenging projects I've ever worked on, and this is before I came to the lab, were on international development, where I've been to places in Africa and I've been to places in Central America, and I've brought places that don't have any electricity at all. And I brought solar panels and batteries and things like that to electrify homes, to electrify schools, health centers, to make a difference in people's lives. And it really, I consider it some of my best work because it's so rewarding. You know, there's one clinic I can think of in Tanzania where they have solar power to power a vaccine refrigerator. And there are going to be hundreds or thousands of kids who are going to get vaccines because we put in these solar panels there. And that's just such a great feeling, such a great sense. Or in Guatemala, where I know of a school where I helped put in solar panels where kids are able to actually study later at night in order to be able to pass state tests and be able to go on to high schools and things like that. And little things that you take for granted. I don't know if you've ever tried to read a book by candlelight or by the light of a lantern. It's really hard, and you end up not being able to do any studies after a certain hour. And if you can only study, you know how much time you spend on your homework, right? If you can only study during daylight hours when you still have other chores and stuff to do, it really limits what you can do. So it's really rewarding. It's really some of my best work, I think, to think about going places and really bringing opportunities to people, to their health, to their education. It's really challenging. In different ways, though. It's not necessarily that the work is that technically challenging, because the systems are pretty simple. It's in terms of you know, thinking about putting together a solar panel for a couple of solar panels for a building and a couple of batteries. It's very different than, you know, you think about, you know, a whole big solar field for a utility. That's a much more challenging project with, you know, solar tracking and all of these things. But the challenges of working with people are very real. It's working with people from different cultures. It's understanding what people value, and that what people value isn't always the same as what you value. It's what's going to be important and impactful for them, not what you think should be important and impactful for them. So the challenges there, I found this with a lot of science, the challenges are mostly to do with the people, that working with people and making sure that everybody's working towards the same goals, and that everybody understands one another and knows why people want what they want. Those are some of the biggest challenges, but yeah, that's some of my most rewarding work, and yeah, I would say some of my most successful.
That is so inspiring. I love that answer. And yeah, working in science is, you know, there are challenges that aren't science, like you said. People are the best part of our jobs, and sometimes they can be the hardest part of our jobs, but you know, that's true with any job. But so that's going to do it for today's session, but we're not done answering questions from students. March is Women's History Month, so we'll keep asking these brilliant women at EERE and ORNL to answer more questions over the next 2 months. Keep an eye out for some more enlightening Q&A.